Assalamualaikum warahmatullahi wabarakatuh. Hello, Mrs. Chika and all of our dearest friends. Here, we are going to presenting about our assignment with title Synthesis and Characterization of Magnetite. Before that, I want to introduce all members. First, me, Anisa Nurizka W, and there is Inne, Zaskya Purwanti, and Anisa Hidayah. Okay, we are moved to the content of this presentation. First, there is a purpose, then a literature review, then a methodology, then a result and discussion, and last is conclusion. Okay, first, purpose in this task is to studying about the process of making magnetite using low energy and characterizing the result compounds using FTIR and PSA. Okay, the literature review of this research. First, magnetite Fa3O4 is the metal oxide with the strongest magnetic properties. One of the advantages of magnetite is that magnetite are absorbent, where its ferromagnetic properties that capable to also being electromagnetic wave through a magnetic mechanism, especially towards metal atoms or ions, which are paramagnetic. From Nuzuli 2013. Second is the synthesis of magnetite. Magnetite can be synthesized using several methods, but the most commonly used is the conventional co-precipitation method. In recent years, the co-precipitation method has been widely used because it is an easy and effective method for synthesizing magnetite nanoparticles with high yield. The co-precipitation method relies on the precipitation and reduction of iron 3-oxyhydroxide, FaOH, and iron 2 hydroxide, FaOH 2 times. This deposition process is influenced by acidity condition and the F3 plus or Fa2 plus mole ratio used by Maya 2020. Okay, then the Fourier transform infrared or FTIR is an instrument that is widely used to determine molecular vibration that can be used to predict the structure of chemical compounds. FTIR spectroscopy is an infrared spectroscopy equipped with a Fourier transform for the detection and analysis of the spectrum results. From Solistiani and Nuril 2018. And then PSA or particle size analyzer. PSA was used to determine the average particle size of lithium iron phosphate or LVP. PSA used the dynamic light scattering or DLS method, which utilizes infrared scattering. Infrared scattering is fired by a tool against the sample so that the sample will react to produce Brownian motion, or is a random motion of very small particles in a liquid resulting from collisions with molecules present in the liquid. From Zulaika et al. 2020.
Methodology. The tools used in the practicum are Becker glass, Erlenmeyer, analytical balance, arologic glass, burette, clamps and stative, thermometer, Wetman 42 filter paper, volume, pipette, oven, hot plate, magnetosphere, file bottle, FTIR or Fourier transform infrared spectroscopy, and PSA or practical size analyzer. The material used in the practicum are iron 2 sulfate heptahydrate, ferric chloride hexahydrate, sodium hydroxide, distilled water, citric acid, magnetic stir, magnetic synthesis, and natrium hydroxide. The working procedure of magnetic synthesis is 2.78 grams of iron 2 sulfate heptahydrate and 5.4 grams of ferric chloride hexahydrate. Its solid is dissolved in 20 ml of distilled water. The two solutions are mixed and stirred and then placed on a hot plate. Natrium hydroxide is added and stirred with a magnetic stirrer until the potential of hydrogen 12 and then settles. The mixture is filtered to spare the participant with Wetman 42 filter paper. The mixture is filtered to spare the participant with Wetman 42 filter paper. Wash with distilled water until the potential of hydrogen is neutral. Then the participant is placed in a watch glass and dry. Characterization of synthesis magnetite using particle size analyzer or PSA. 5 mg of synthesis magnetite was put into a glass-filled bottle, added 5 ml of 0.1 molar citric acid, and then sonicated for 15 minutes and characterized using PSA. After that, characterization using FTR. Result in discussion. The practicum carried out was the synthesis of magnetite from iron 2 sulfate heptahydrate and ferric chloride hexahydrate. Color solution of iron 2 sulfate heptahydrate is greenish yellow, while for ferric chloride hexahydrate is brownish yellow, in which each of the solution contains iron 2 plus ions and iron 3 plus ions. After that, the two solutions are mixed in a bigger glass and produce an orange-brown solution color with the equation like that. The precision of mixture of ferric salt with chloride ions make the magnetite particle size smaller. The average diameter of magnetite is strongly influenced by the ratio of iron 2 plus science concentration and iron 3 plus ions in a salt solution.
The mixture was then placed on a hot plate with a temperature of 50 degrees Celsius at a speed of 112 revolutions per minute and was given a magnetic stirrer so that the mixed solution became homogeneous. The initial pH of the mixture is 1, which is then added with sodium hydroxide drop by drop to provide an alkaline atmosphere so that magnetite can form because sodium hydroxide functions as a precipitate. The following is the reaction of adding sodium hydroxide. While the purpose of heating to eliminate the use of sodium hydroxide, the addition of sodium hydroxide was continued until the pH of the mixture was 12. The resulting iron oxide compound had a very strong response to the magnet when the magnetic rod was brought closer. The final pH obtained after adding sodium hydroxide and heating was 12. Then the solution was filtered to spare the black precipitate from the filtrate. Then the precipitate is washed using distilled water. Washing is carried out with the aim of neutralizing the pH of the precipitate so that the pH of the precipitate is equal to 7. Then the precipitate is dried. From the calculation result obtained the theoretical mass of 2.32 grams. The resulting magnetite powder was characterized using FTIR and PSA. FTIR is used to predict functional group while PSA serves a determinant of magnetite particle size. In the FTIR graph of the observed data, it can be identified the types of bonds in the synthesized result. The aim is to determine the typical 3 pegs of a chemical bond in the synthesized particle. In the graph of the FTIR result, the absorbance peaks are obtained at wave number 533.03 cm-1, 1630.76 cm-1, and 3129.41 cm-1. This indicates the vibration of the FAO tetrahedral covalent bond, OH stressing, and OH bending, which confirms that the magnetite phase had been formed. The FAO vibration obtained the relevant to the reference magnetite wave number of 550 until 630 cm-1.
The iron oxide nanoparticle powder resulting from precipitate was also characterized using a particle size analyzer, so that the particle could be determined. The particle size obtained in the characterization result is 6544.1 nanometer with a homogeneous level of 1.176. This homogeneous level is influenced by manufacture, one of which is the magnetic weighting and the dilution factor. Particle size can also be affected by several factors. One of them is pH. The valency of the iron salt used also plays an important role in determining the size of the iron oxide nanoparticles. In the co-precipitation method, generally a black precipitate of iron oxide nanoparticle is formed after mixing the iron salt solution and the base. The reaction is as follows.
Conclusion: the analysis of functional group formed in the sample is determined using FTIR characterization. Absorbance peaks were obtained at wave number 533.03 cm-1, 1630.76 cm-1, and 3129.41 cm-1. This indicates the presence of FAO tetrahedral covalent bond vibration, OH tracing, and OH bending, which reinforce that the magnetite phase has been formed. The precipitate iron oxide nanoparticle powder was also characterized using a particle size analyzer. In order to determine the particle size, the particle size obtained the characterization result is 6544.1 nanometer with a homogeneous level of 1.176. This homogeneous level is influenced by manufacture, one of which is the weight of the magnetite and the dilution factor. Particle can also be influenced by several factors, one of which is pH.
Next is the bibliography that we use, and thank you. Wassalamualaikum warahmatullahi wabarakatuh.